Electrostatic Balance Lab. Introduction, Materials, and Procedure. Students will build a balance that can weigh the electric force. And when we talk about weigh, we're talking about forces, right? Because if you go back to dynamics, the weight of an object is mg, and that's a force, which is in Newton. So that's kind of what we're doing here with the electric force. The balance consists of a straw balanced on its center fulcrum with two pith balls on the ends. Students will observe what happens when they bring a charged rod close to a pith ball on the balance, and what happens when they touch the rod to the pith ball. They will make these observations for different rods and rubbing materials as well. We have a lot of materials per group for this lab. Okay, they're all rather cheap, but there's a whole lot of them here. A strip of acetate, a strip of vinyl, a wool cloth, a cotton cloth, two pith balls, some monofilament line or fishing line, a plastic vial, an index card, a straw, two paper clips, common pins, and glycerin. Timing. This should be a one-period lab. 5 to 10 minutes for introduction, 20 to 25 minutes for observations, and then 5 to 10 minutes to wrap it up. What we anticipate is the charged strip, regardless of the material it's made out of, will initially attract the pith ball, making the scale move up or down towards the strip. Now, what is a pith ball? Well, it looks like a ball, and it actually looks like a little piece of cork. It's a type of plant material that is a non-conductor, but it is very easy to put charge on and off of it. So that's a pith ball, and you hang it by a string here, non-conducting string. And if the pith ball is touched by the strip, we're back down to here, they will repel. For best results, perform this lab in a dry environment. Humidity will interfere with the results because charges will bleed off your objects into the atmosphere, and you won't get the good repelling and attracting forces. We have to do a bit of construction for this lab. 1. Cut a hole in the bottom of the paper cup just large enough for the vial to slide in and stay snug, enabling the vial to stand and not fall over. Fill the vial 3/4 full with glycerin or oil, and then with the index card in a landscape orientation, wrap it in a cylindrical shape so that the wide side of the card forms the circumference of the circle and the narrow height of the card forms the length of the cylinder. Insert this card into the vial and let the card expand out to line the inside of the vial. Cut 2 notches on opposite side of the index card circular top, large enough to hold the straw in place, and then cut 2 more notches on the opposite sides that are both 90 degrees away from the first 2. Make these notches smaller, just large enough to hold the pins in place. More steps. And don't worry about this. You can use these instructions for reference where we have a video coming up that'll demonstrate what to do. So let's bend one end of a paper clip out and away and insert the larger side of the paper clip into the straw so it fits snug. If it is not snug, widen that part of the paper clip. Stick the pith ball onto the end of the paper clip sticking out of the straw on both sides. Insert a pin through the center of the straw with the point just barely piercing the other side. Insert another pin through the center of the straw but perpendicular to the first one. This time, push it far enough so that half of the pin is on one side of the straw and the other end sticks out on the opposite side. Balance your pin straw system on the index card in the vial so that the pin with both sides poking through the straw rests in the small notches. Make adjustment with the paper clips and pith balls to ensure the straw balances on the index card. Okay, the construction part of this lab is now done, and we're going to do the experiment. First, rub a strip with material and hold it near one of the pith balls. Write down your observations. Next, touch the strip to the pith ball and record your observations. After you do this, touch the pith ball with your finger to discharge it before testing another charged object. You want to pull the charge off of it. Repeat steps 11 and 12 with different strips and rubbing cloths and record your observations. Then try comparing the different charged materials by holding them on opposite pith balls. Observe how the scale moves and write down your observations. Here's a picture of what your construction should look like. Right at the bottom, here's our vial filled with glycerin, and then you have the index card inside of it. Then we have pins on the straw, which are going to enable a straw to rock back and forth on that fulcrum. And on either ends of the straw, you have a paper clip that is holding your pith ball into your construction. Record your data for the interactions between the strips after you have rubbed them with the wool cloth and the cotton cloth, and when they are brought near or when they are touching the pith ball. And tell us what happens to the pith ball and scale in the table below. Please click over here to see exactly how to construct the apparatus and how to run the experiment. Obviously, the words we went through a few slides ago are great and it tells you exactly what to do, but it's always nice to see it done, to see it make sense to you.